Hello everyone, welcome all to Physics with Asnotrix. So in this video we will discuss about 2023 CPET Physics question paper. So let's begin. And here is our first question, that is, if three particles each of same mass are at points 1, 2, 3, 2, 3, 4 and 3, 4, 5, then the center of mass of the system is, and the options are 132, 234, 431 and 345. So let's see what will be its solution. Here we can see, according to the question, there are three particles each of same mass, and at point 1, 2, 3, 2, 3, 4 and 3, 4, 5. Then we have to calculate the center of mass of the whole system. So we know that the center of mass of x point will be equal to summation over mi xi by summation over mi, because here all masses, all particles have same mass, so here we can consider it h m, and the point x1 for the particle 1 is 1, for particle 2 is it's 2, and for particle 3 is 3. So by putting the value of all these x value, we can found the x cum h2, y cum h3 and z cum h4. So our final answer will be r cum is equal to 234. So here 234 is the right answer. Then if the particle is at rest in a rotating reference frame, the magnitude of Coriolis force acting on the particle is, and here the options are m omega square by r 0 and m r omega. And it has been asking that what will be the magnitude of Coriolis force when the particle is at rest. So we know the formula for the Coriolis force, that is equal to minus 2m omega cross v. Here omega is the angular velocity and v is the velocity and m is the mass of the body. So according to the question, because the particle is at rest, so we can consider here v is equal to 0. So by putting the value here, we can find that the Coriolis force will be 0. So here the answer C is the correct option. Then moment of inertia of a solid sphere about a tangent is. The options are 2 by 5 mr square by 2, 7 by 5 mr square and mr square. So we have to calculate the moment of inertia of the solid sphere about its tangent. We know the moment of inertia about the center of a solid sphere is 2 by 5 mr square, and so by putting the applying parallel axis theorem, we can find the moment of inertia about its tangent, that would be equal to 2 by 5 mr square plus mr square, and this mr square comes from, because here the mass of the sphere is m and the distance from center to the tangent is r, so this is 2 by 5 mr square plus mr square, that would be equal to 7 by 5 mr square. Then the theoretical value of a Poisson's ratio lies between, and here the options are minus 1 to plus 0.5, minus 0.5 to plus 0.5, minus 1 to plus 1, and minus 2 to 0.5 or 5, I don't know. So here the correct answer is minus 1 to plus 0.5. Then the depression at the middle of a light double cantilever supported at the ends and loaded at the middle is proportional to. Options are L square, L cube, 1 by L, 1 by L square, where L is the separation between the ends. So we know that when it is supported at the ends and loaded at the middle, uh, this is proportional. This is equal to omega L cube by 48 y ig. Here L is the separation and y is the Young's modulus, where ig is the moment of inertia. So from here we can get that the value is proportional to L cube. For additional information, we can know that the depression at the middle of the light cantilever free at the ends is given as omega L cube by 3y ig. And then if the pressure inside two soap bubbles are 1.01 atmosphere, and 1.02 atmosphere, the ratio of their respective volume are. And here the options are 2, 4, 8 and 16. In both the cases, that is the bubbles, the outer pressure or atmospheric pressure is 1 atm. And in the first bubbles, it has been given that the pressure inside soap bubble is 1.01 atm, and here the excess pressure will be equal to 1.01 minus 1, that is equal to 0.01 atm. And in second bubbles, the pressure inside the soap bubble is 1.02 atm according to the question. So here the excess pressure will be 1.02 minus 1, that is equal to 0.02 atm. And we know that the pressure is inversely proportional to the radius, that is P1 by P2 will be equal to R2 by R1. And from here we can found that R2 by R1 is equal to 1 by 2. And again we know that the volume is proportional to R cube. So because in the question it has been asking that what would be the ratio of their volume, so we can take it as V1 by V2 is equal to R1 by R2 whole cube, that would be equal to 8. So our answer is 8. Then if a planet moves around the sun in an elliptical orbit with semi-major axis A and time period t, then t is proportional to. The options are a square, a to the power 1 by 2 and a to the power 3 by 2. So we know that the Kepler third law say that t square is proportional to a cube, and from here we can get that t will be proportional to a to the power 3 by 2. So our final answer is option D, that is a to the power 3 by 2. Then which statement is not true for central force problem? And the options are central force is conservative. Yeah, this is correct. Angular momentum is conserved. This is also true. Aerial velocity is constant. This is also true. And the last option that says mechanical energy not conserved. So this is not true. So here the right answer will be option D. Question 9. The magnitude of a gravitational field at the center of a solid sphere of radius r each. The options are 0, mg by r, mg by r square and mg by r cube. So here we can see a solid sphere with the radius r and the center is at O. So the gravitational field inside the solid sphere is given by E is equal to gm by r cube into x, and here basically the x represent the distance from the origin where we have to calculate the field intensity. So because in the question it has been asking that at the center. So at the center the x would be equal to 0, and so the magnitude of gravitational field also would be 0. So here the correct answer is 0. Then the time period of damped oscillatory motion is, and here you can see the options. And it has been mentioned that the P is a damping factor where M is mass and K is the spring constant. So let's see what will be its final answer. So for damping, we know the equation of damped motion, that is equal to m d square x by dt square plus p dx by dt plus kx is equal to 0. And from here we can get that d square x by dt square plus b by m dx by dt plus k by m x is equal to 0. And again here b by m is equal to 2 beta and k by m is equal to omega naught square, where omega naught is the natural frequency. So we have to calculate the final frequency, that is omega x is equal to root over of omega naught square minus beta square, and the time period will be t is equal to 2 pi by omega x, that is equal to 2 pi by root over of omega naught square minus beta square. So by putting the values of omega naught and beta here, we can find the final answer as 2 pi into root over of m by k into 1 minus p square by 4 km to the power minus 1 by 2. So this solution matches to the option 3. So the final answer is option C. I hope you all enjoy this session. So for more videos, please do like, share and subscribe. Thank you.